of workers and substitute for others. And more precisely, we're going to have both a theoretical component and an empirical component of this paper. And on the theoretical side, we're going to build a dynamic ROI model. So the ROI model part of it is relatively straightforward. We're going to have firms that are heterogeneous in terms of their technologies. We're going to think about task technology. So firms are going to use different combinations of tasks, and workers who have different skills at doing these tasks. And so this setting, where some workers are relatively better at some types of tasks, and some firms use those tasks more intensively, is going to create firm-worker complementarities. Okay, and the difference, so this part is pretty standard, but the difference we're going to have here is that workers can invest in accumulating skills. So the distribution of skills is going to evolve endogenously, so we're going to have dynamic skill accumulation. And you might think that there are two mechanisms through which this might happen in the real world. So one is you have a shock, and then all the existing workers in the workplace, in the workforce, update their skills to be able to use this new technology more effectively. And the other is that, so they retrain. And the other is that entering workers who are coming into the workforce, train in a way or adapt in a way to adjust their employment in response to the shock. And so we're going to focus entirely on the second mechanism. We're not going to have retraining of the older workers. And I'm going to show you some empirical evidence to suggest that this is actually the more relevant mechanism, the young workers changing what they work on. Okay, and on the empirical side, we're going to have our shock is going to be the adoption of high-speed DSL internet in Germany. So it turns out that because of exogenous, predetermined things about the German telephone network, there's quasi-random variation in the timing of the adoption of high-speed DSL internet across German regions. And I'll go into much more detail about this. And so we're going to combine that with matched employer-employee data. So the shock is at the local labor market level. We're going to combine that with matched employer-employee data. And then we're going to estimate dynamic responses of inequality and average wages and employment shares in response to the shock. And so these are exactly the data equivalents of what we need to estimate for the model. And that allows us to then test predictions about skill accumulation and reallocation that the model suggests should happen. Okay, so I have a caveat. This paper is very preliminary. We're not done. We were hoping to be more done at this point, but we're not done. So from this point on, everything is going to be, we're going to get there, but we're not there yet. Okay, so I'll show you some preliminary evidence about the reallocation, but we don't have everything yet. And then where we're going to go with this is we can actually estimate our model by matching the theoretical impulse responses to the empirical impulse responses. And once we've done that and we've identified the parameters that we need to, we're going to have hopefully some fun and see what we can learn from the adoption of the internet to how economies would adjust to other technologies. Okay, and so those are the kind of factors we're interested in. And we also want to think about what the long-run inequality and output elasticities will be, or what a model suggests that they will be. Okay, so we're going to match the impulse response functions to the short and the medium run, and then try to make predictions about the long run. But all of this, we've worked out how we're going to do it, but we haven't done it yet, so there's going to be no counterfactuals today. So I'll just show you what we're planning to do, and hopefully it's going to all work out in the end. All right, so before I talk about the model, let me show you some of the stylized facts in the data. So many of these are going to look similar to facts that you might have seen from work by author Dawn Masamoglu and others for the US. So we're just going to show you what this is like in the German data. So between 1997 and 2012, inequality as measured by the standard deviation of log wages increases by 11. So the dark line is the dark bar is total, and this one is. So this kind of, so we've done, this is between 7 sectors and 3 occupations and districts. So we're trying.
Why would we care remote about a label that people have that is not?
So we're thinking about certain types of people, so the technological change happening that complements certain types of people in certain firms or in certain sectors. So we want to look
directly.
Um,
We have the data, or why don't you do it directly?
So we have, this is total inequality. We have done it between occupations. It looks pretty similar. In terms of explaining, so the between occupation or the between sector combined with narrow occupations explains about half of the overall increase in inequality. But this is what we've disclosed.
You're looking at people, right? The thing is that you're composing between and within. So she's looking at people.
I don't see many people there.
No, that's the data that she's using is individual data.
Yes, sorry, I mentioned that. Maybe you missed it.
Now people are also defined by where they work or how they work.
Okay, so the between sector occupation inequality explains about half of the overall increase in inequality over this period. And then we looked at some other characteristics of what is happening in Germany over this period, and we see, so this graph shows you occupations, so we have about 120 occupations in our data. Occupations ranked by their analytical content, and I'll talk about the data later and I'll explain where we get that from. And what we're showing you here is the smooth change in the employment share across occupations in Germany over this period. Okay, so there's a similar figure in Otter and Dawn for the US, and you can see that employment is shifting towards the more analytical occupations in this period. Okay. During this same, towards analytical, and these are analytical non-routine occupations, that's what we're ranking them on. During this same period, we also look at what is happening to the ages of workers working in these occupations. We find the reverse, so we find that older workers, so the smooth changes in mean age by occupational analytical percentile indicate that the more routine occupations are aging faster over this period, substantially faster. And this is against the backdrop that Germany as a whole has an aging workforce over this period. So the fact that analytical occupations are not really aging that much suggests that it's mostly young workers that are entering into these analytical occupations. We can look at that in more detail, and so what I have here are the employment shares of new workers and of cohorts entering the labor market at 5-year intervals in our data. And we start with the blue line, which is the first cohort that we have. And there, the employment distribution of young workers was much more towards the more routine occupations and less towards the analytical occupations. And this changes over time, so young workers start to enter more and more analytical occupations. And there's also some evidence of polarization. So they're moving out of the middle, they're entering a little bit more into the very routine occupations and then into the most analytical occupations by the end of our data. Okay, so this is very suggestive that a lot of the reallocation that's happening, the shift of the German economy towards more analytical occupations is happening because of the actions of the young workers that are entering the workforce. And so that's why we're going to motivate, that's how we're going to motivate how the scale distribution updates in this model. So when we talk about the model,
so that definition doesn't change over time, like doing some stuff of analytical analysis.
No, so that is it's both a good thing and a bad thing. So we actually only have one measure of occupational analytical content. It turns out that for Germany, this kind of data is not super easily available, where you can decompose an occupation into what task the occupation is doing. So the FTZ, where we get this data from, they have one for 2011. It's a 2011 measure. So it's an end measure of what the analytical content of an occupation is. And so we apply that to the occupation throughout this. I mean, it would be nice to be able to look at that in a little bit more detail, but that just doesn't exist. Not that we know of, anyway. We try to ask. Okay, so the model, we're going to have a small open economy that is going to have firms and workers, and firms are going to produce using different technologies. Workers are going to be heterogeneous in their skills for operating these technologies. So we're going to denote workers by I and firms by K, where we're going to assume that there are two firms. So there's going to be K1 and 2. And we're going to assume that there's free mobility across firms. So world demand for the output of firm K is just XKT, which is the price of firm K raised to power minus theta times ZK, where ZK is a demand shift. So this is a small open economy, but it would be the same as if we had a closed economy with CS utility. Okay, so so the output of firm K at time t is just an aggregate over the output of each individual worker of type I times the quantity of the types of quantity of workers of type I that the firm employs. So alpha I is the output of each worker, and the output of firm 2 is, we assume, alpha I times this function sigma I, which I'll explain in a second, raised to the power of beta times, again, the quantity of workers of type I that the firm employs. So here we're going to assume that this function sigma I is the worker's relative skill in cognitive and routine tasks. Okay, and we're going to assume that, this is just an ordering assumption, that sigma I increases in I. So high I workers are relatively better at cognitive relative routine tasks. And beta is going to be the relative cognitive task intensity in firm 2's technology. Okay, so assuming that beta greater than 0 combined with sigma I increasing in I implies that firm 2 is the technology that complements high types. So firm 2 is the cognitive intensive firm. Okay, and then the firms take the wage profile of the price that's given, and they choose the quantities of workers of each type to maximize their profits. So that part is relatively standard. So we talk a bit more about the workers and what they do in the model. So we critically assume that there's free mobility between the two firms. So we have no frictions in workers being able to move within the period from firm 1 to firm 2. So all the focus is really going to be on the skill accumulation. So the workers have flow utility, which is just log wages, so they're not saving it, they consume their wages in every period, and that is the maximum of the wages they can get in firm 1 versus firm 2. We're going to assume an overlapping generation structure, so there's going to be random births and deaths that follow a process with rate delta, and we're going to have a skill accumulation technology which works as follows. So when you're born, you get a one-time chance to acquire human capital. Okay, so there's no skill updating after your initial choice of type, or after your initial draw of lifetime type I. So at birth, workers choose a costly lottery, which we're going to call S tilde, over their lifetime type I. And this cost for this lottery is proportional to the Kullback-Leibler divergence from the uniform. Okay, so if you don't want to pay the cost, you get the uniform. So now I want to talk a little bit about this to really explain that what we're not doing here, we're not saying that it's just very costly to acquire cognitive skills. Okay, so skills are multidimensional in this framework. So workers have, you can think of a worker having a cognitive ability and a routine ability. And so there's just different bundles of skills available that are possible. And what this cost is doing is it's preventing, so all workers would ideally like to be the best type, right? So that's what they would like to be. That is very costly. So what this cost is doing is saying it's very costly to lower the variance of the draws to one specific point in the distribution. So you pay a little bit less of a cost, but you get some variance, and so you could end up with, you always end up with all types in equilibrium. Okay, so
this is supposed to be birth per se, or this is like college? When you leave college?
I think it's when you leave college. Well, it's when you leave. It's kind of compressing birth to when you leave college because you're kind of acquiring the human capital and I guess some of you're getting in college to be able to maybe it's before college, right?
So you're saying there's a margin of getting college to begin with, getting a PhD plus taking a postdoc.
Yeah. So that's why I don't want to say it's the end of it where you've already chosen all your types, but you've made a decision at some point on whether you want to.
But there's no learning after that.
There's no learning after that.
So before they choose this lottery, are there any differences across people?
No, no. So
But in
Born
equality,
and
they
then-
will choose different, they will choose the same lottery and.
so everyone is going to choose the same
And
lottery.
then they will
Right.
different realizations.
Yes, exactly.
And that will cover this two-dimensional space.
So I'm sorry, I'm just on the structure, so I goes from 0 to 1?
Yeah.
And everybody has some skill for each of the I's from 0 to 1. So what does it mean their type is I?
So it
Over
just
their lifetime type. I from 0 to 1 are tasks.
I from 0 to 1 combinations of tasks. So
Sorry, go back a slide. So there's,
this is where part 9. Workers are denoted by their type, which is the combination of the tasks. So I can show you
so every worker is one number between 0 and 1.
two numbers. So you can think of it as workers performing routine tasks and cognitive tasks, and every worker of type I has this cognitive ability and this routine ability.
For one, okay. I guess I'm struggling. So there's a bunch of tasks between 0 and 1.
Those things have words. In all of those words, the task, a worker is I, and she produces Y or I, and she chooses which sex to go to. Task is just overhead that she uses the sex.
Is that right? So this, I shouldn't think of tasks. A worker is I, and I can either do cognitive thing or a manual thing.
A worker has two abilities. It has a cognitive and a
Because
manual
what
ability.
people don't get is how you go from a one-dimensional index I to two tasks. So it's not, I think that's not clear. No, because you know, we have the one-dimensional index I, and then somehow that, from the lottery, you get
Right.
two drops.
Yeah.
That part is not clear. You have to elaborate it.
So I can think of every combination of AC and AR together and put them somewhere between 0 to 1, right? So that's
So that's, in a way, you can have exactly the same equation without the T.
without the
Without the task whatsoever.
yeah.
There are two firms and you choose which one to go to. And you use the T word to describe whether you go to work or the other.
Why do we need the 0
So-
to 1?
Maybe this is going to be easier. So I can define. So if I think of I as thinking about your relative skill in cognitive versus routine, then so
it's
I
like
is
a
just
measure of your comparator agreement.
yes.
And then sigma is increasing in I? I mean,
Sigma
it's
is
the order
increasing in
of
I.
things, okay.
Sigma is increasing that. Yeah.
And there's no absolute advantage.
There's no absolute advantage. That you're always better? No.
I just mean, if I know I'm twice as good at cognitive routine, that's it. I don't need to know that I'm 200 and 100, that's the same as 2 and 1.
It's the same as
There's just only. it's
no,
only
that's
advantage.
because you're
Everybody's
also-
2 and 1.
Sorry, alpha measures it to the advantage.
Yeah, alpha measures it,
Right,
exactly.
advantage.
that's right. Alpha measures absolutely.
Alpha measures, say it again?
Yeah,
So
so
alpha
advantage and sigma they comprise advantage. Because
So
it's
the
bigger
200 and 100 will have a high alpha, and sigma will be the same for the 200 100 guy and the 2 and 1 guy. The 2 and 1 guy is going to have a low alpha.
But they have different alphas too.
Yeah, they have different alphas. Alpha is how much they produce.
Each I has a pair of GGs. You can define it as alpha and sigma for each I.
But the ordering is just on the sigma.
Ordering is on sigma. So
What do we care about alpha? That's just for alpha?
it's for alpha.
But it doesn't affect how you sort into one firm versus another.
How you sort into one firm versus another. It's going to affect your wage.
Doesn't affect any sort, that some people have high alpha.
Some people have high alpha.
It affects your wage, the
Your
level of your wage,
Yeah.
but not the relative wage.
Not the relative wage. And that's going to be clear once I show you the graphs. So, okay. Do I move on? Oh, okay. All right. So workers of type I that are born at time T have lifetime utility. There's just the present discount value of their wage in every period after that. And so the skill accumulation problem for a cohort born at time T is to maximize their utility and subject to paying the cost for a particular skill lottery. Okay, so this is forward looking. They're going to tilt their skill lotteries towards types that have high utility. Right, so that's what you will see from this problem. So you can think of this as directed skill investment. So if there's a shock that increases the utility of certain types, then the entering cohort at that period is going to tilt the lottery towards those types. And this parameter psi is going to govern the sensitivity of skill investment to changes in the wage distribution. Okay, so this is going to be one parameter for the speed of convergence later. Okay, so we can show then that the equilibrium skill lottery is just simply a multinomial loaded function, a continuous time multinomial loaded function. And you can see that there's going to be positive mass on all types in equilibrium, but it's going to be tilted towards types that have higher utility. Okay, and you can get something like this, I think, also just by having a discrete number of types and then having, cost shocks that are type 1 extreme value. We want to do this in continuous time, and so this is just the continuous time version of it. So the skill distribution in the economy then satisfies the Kolmogorov forward equation. So, and that is pretty straightforward. So there's the evolution of the distribution. You lose delta because of the deaths of existing workers, and then that delta are born with the new lottery at that period, time t. So delta is kind of the boring parameter, so that also is going to govern the speed of convergence, how fast new cohorts enter and die. But it's kind of the less interesting parameter that we're going to estimate. And this is just the definition of, I don't have a watch, so can I get a sense of the time? I don't know too fast.
You have plenty of time.
Okay, good, so I can slow down. So this is just the definition compared to the equilibrium. It's standard, so households often choose the lottery and which firm to work in, given the wages. Firms choose the quantity of each type they want to hire, given the wages and the prices. The goods and labor market is clear, and the skill distribution satisfies the Kolmogorov forward equation. So this is our state variable, and then the only control variable is the lottery. Okay, so I'm going to try to use graphs basically for the rest of the models, like on method intuition, without going into all of the math. So this is just the static equilibrium of the stationary equilibrium of the model. So the left-hand side is the standard Roy model. So firm 1 offers every type a wage, and firm 2 offers every type of wage, and there's going to be a unique intersect. So there's going to be a threshold, we're going to call it L0, and all types below L0 are going to work in firm 1, and all types above L0 are going to work in firm 2. So the actual wage profile in the economy is going to be this thick blue line. So the right-hand side is just demand and supply. So demand is exogenous, and here I'm defining X as the relative quantity of firm 2 relative to firm 1, and P is the relative price of firm 2 relative to firm 1. And so demand is exogenous and upward sloping, and supply is upward sloping, and just so the types that are working in firm 2 divided by what the types that work in firm 1. Okay, so this is all very standard. So this is okay. So we can also rewrite that equilibrium skill lottery in a manner that really makes it very explicit that this is forward looking. And so all we're doing is defining this function we call gamma, which tells you that so gamma is the present discounted value of the relative wages, okay, and 1, max of the 2. And so this is really highlighting that the skill lottery, so skill investment is purely forward-looking. So the workers forecast the path of future prices and choose the lottery at the time that they're born. Okay, so unsurprisingly, the stationary skill distribution is just the lottery. You would have seen that from the Kolmogorov equation already. And we can write that as a function of relative wages. And we do this just to highlight that the stationary skill distribution as a function of relative wages implies that there's a constant skill supply elasticity. Okay, and that is this combination of parameters psi over rho plus delta. And so this is like a macro foundation for static models like Asimoglu and Otter that are static but then assume this ad hoc skill supply elasticity. Okay.
You need that equilibrium is the same no matter what initial conditions are.
So the long run equilibrium is going to be identical.
The final equilibrium is an over. Let's define equilibrium as an object. So say, is the equilibrium path of prices the same in two economies of different emissions instead of equilibrium prices?
The equilibrium given the parameters. Yeah.
No, that's saying that the prices are the same, no matter there's no dynamics of no stationarity on the prices. Of course, people have their own initial skills of physiology dynamics. New incoming entrants are independent of whether it's allowed itself to say or not.
Mm-hmm. The new incoming entrants are independent of who was alive?
Whatever happened to the other guys who are alive.
Yes. So they just forward looking.
Everybody's forward looking. There is no interaction between agents and people.
There's no interaction between agents and people. Okay. So we're now going to bring in an MIT shop, which I think we're doing it. I have no affiliation with MIT, but my team does, so we're going to have an MIT shop. We're going to have an exogenous demand shock that increases the relative demand for the skill-intensive firms. So this is firm 2. And we're doing this just to illustrate how we're going to focus on the transition. So we're going to look at the short run, the medium run, and the long run. Okay, so demand for firm 2 increases, and so the relative prices increase. And so firm 2, given the skill distribution economy, offers a higher wage to all types, and so that changes, that immediately changes the cutoff, which becomes lower. So L moves to L epsilon, and workers move from firm 1 to firm 2. This also means that relative wages are higher, so entering workers will start to tilt their skill distribution towards these higher types. Okay, so in the medium run, workers will enter as higher types, and that will increase the supply of firm 2's output relative to firm 1 and shift in the wages. So that in the medium run, not in the long run, so medium run and long run. So the threshold will then move back up. Okay, so L is going to move first down and then back up, and output will increase further, and prices will first rise and then fall a little. Yeah, supply adjusts. So this is just, this is very standard demand and supply, but we're just going to work through this in more detail. This is obviously a fixed point problem. We're going to solve it that way. So this is exactly what we're going to focus on in this paper. So we're going to study adjustments after one-time permanent increases in either Z, or I'll show you in a minute, beta. And beta was the complementarity of cognitive skills to firm 2. Okay, so as you could see from the graph I just showed you, the equilibrium is a fixed point. And we're going to log linearize the simplicity, so it's going to end up being a 2x2 system in relative quantities x and relative prices, the present discounted value of relative prices q. And this is a little bit like a Q theory of skills investment. So basically, when Q is high, the marginal value of an additional worker moving to the high skilled firm into firm 2 is high, and so you increase investment. The only caveat here is we have heterogeneous skill types that are not perfect substitutes, and so what's going to happen is that the convergence is going to be determined not just by the adjustment cost parameters, which here are the psi on the cost of adjusting skills, and delta, which is the birth and death rate, but it's also going to depend on the heterogeneity of skills from the point of view of the cognitive firm. So if If cognitive skills are very widely dispersed and are very heterogeneous, then workers know that a slight increase in their type is going to lead to a large increase in their wage. That's going to increase the rate of convergence. Okay, and then so that's the model. And then what we're going to actually focus on is what happens to relative employment. So I'm going to define epsilon as relative employment in firm 2 relative to firm 1. Between firm wage inequality. So I'm going to define omega as the average wages in firm 2 relative to the average wages in firm 1. This is between firm wage inequality. And then average wages. So y is going to just be average wages. Okay, overall average wages. And I mean, this is I could probably skip this. This is just saying that when Q is high, you increase output and Q falls. So it's just a 2x2 system. So let me start by showing you the dynamics after the demand shock, which is a very simple case and very intuitive. So once once the demand shock happens, so first in the short run, there's immediate movement of workers into the high-skilled firms, so relative employment increases, and then it increases further to the new steady state as entering workers shift their skills towards
this parameter psi on the cost,
Mhm.
you're thinking that this is completely independent of number of people trying to switch and things like that, or do we think that as the economy moves and more people want to re-optimize that parameter should react to that? Because lots of these transitions will depend on that parameter, so how small, how fast. So that looking at that parameter, you're taking that parameter independent of relative skill supplies and things like that. Is that important assumption? Can we?
That's a good question. We're doing it this way to keep things very simple, and
No, I
also
understand.
because
I'm
we
asking,
see.
what do you think? That's fine. I understand what you do.
I think that it appears in Germany that most of the changes are really happening through entering people. So I think that we think it's a reasonable assumption to make to start. It would be a nice thing to try to generalize a little bit more, but again, this is pretty early stages. So relative employment increases to the new steady state. Inequality first increases a lot because the average wages in firm 2 go up and firm 1 moves. And then it decreases as the supply of skill types increases, and so it decreases down to steady state. And then average wages increase and then keep increasing to the new steady state. So here we have, this is in some sense the slightly more boring shock. The short-run elasticity of inequality is larger than the long run. So you think that if you see an increase in inequality, you're going to expect it to fall later and output to increase further. The more interesting case is the beta shock. So this is again, we're shocking the complementarity of high skill types to firm 2. Okay, so that actually, that is going to end up changing the wages offered by firm 2 for all types. So now the firm 2 now offers very high wages for the very high types. Okay, so what happens here is more interesting. So initially the threshold that was here, 0 was here, is going to shift. There's going to be worker displacement. Okay, so the marginal types move out of firm 2 into firm 1. So there's going to be a fall in relative employment. And then it turns out that when you have this type of shock, there are parameterizations of the model where you can actually get non-monotone convergence to steady state. So I'm going to show you an example of this. So in this case, relative employment keeps falling, and then eventually goes back up to steady state. This is because when this shock happens, there's an incentive for entering workers to polarize their skills. So entering workers are going to enter at very high types or relatively low types. Okay, so the skill distribution is going to polarize, and until the entry of workers at very high types is high enough, you're not going to get this turn upwards in relative employment. Okay, so you're going to first have a decline and then an increase. Inequality?
So why is it that increasing complementarity shifts as correct at the rate and not it's not a shift up? Which is what I mean. Increase complementarity, right? And then the wages of firm number 2 are kind of increasing for this high tariffs decreasing for the low tariffs. So I see the reason of the shift outwards, right? So now, increase component tariff to the money, trying to the school, right? So what am I missing?
So you're saying it should shift that way?
Yeah.
Oh, because when you do that, it's also a supply shift. So supply shifting in, so relative prices for firm 2 are falling. Okay, and this intercept, when it eventually gets there, is the price of firm 2. Okay, so price of real price, yeah. So the opposite happens with inequality. So first you have a small increase. Okay, so wages in firm 2 go up and there's some displacement. But as skills polarize, there's an inequality increases and then decreases down to its new higher steady state. So in the new steady state, inequality is higher than the original steady state because of this beta shock. And then output increases and then keeps increasing. Okay, so this in some sense is what we think the more interesting shock is. So here we have workers displaced in the short run and polarization of the skill distribution of the economy. And this is what we think we might be seeing when we look at the impulse response functions and patterns in the data. What's also interesting about this is that the increase in inequality, which is also the increase in the average returns to skill, coincides with a decrease in the marginal return, which is Q. Okay, so this is something that has been highlighted as happening in the labor range. Okay, now I need to speed up a little, but it's good because this is the slightly more incomplete part of the paper, so we, all right. So empirical application is the adoption of high-speed DSL internet in Germany. And we found this in a very interesting AER paper by Gold and Heiblich that's looking at voting behavior. So I don't know if anyone's familiar with it, but it's actually a really nice application. So it turns out that when Germany started rolling out high-speed DSL internet in 2000, it was largely complete by 2007. But the way they initially rolled it out was to use existing copper wire telephone networks, telephone lines. Okay, and these wires can also transmit internet. So you can bundle the internet wire with the copper wire line. But this only works for a certain distance from the main distribution frame of where the copper wires originate. Okay, so as soon as you get beyond 4,200 meters from an MDF, a main distribution frame, the copper wires can no longer supply high-speed internet. So then the question is where these MDFs were, and it turns out that the locations of these MDFs were determined in the 60s, a long time before they thought about high-speed internet. And since distance doesn't really matter for a telephone network, these MDFs were located wherever they had a supply of large available empty buildings. Okay, so the distribution is not really determined by what you think would make certain regions more likely to have internet faster. When MDFs to add on the internet to did not exist for municipalities, it was extremely costly to lay down an entirely new network to get internet, so those places got internet a lot later, high-speed internet a lot later. Okay, so we get quasi-random variation across German regions that comes from this. So basically, we're going to use the location of these MDFs in 2000 to generate exogenous variation in the cost of supplying internet to a region, and so exogenous variation in adoption time. Okay? We're going to bring this data together with the linked employer-employee panel data from the FTC, which I'm guessing everyone is more familiar with, which we have from the years 1990 to 2014. We only have district-level information from 1997 onwards, so that's what you're going to see in impulse response functions in a minute. And again, we get this occupation task content information from a division of the FTC called BerufNet, and it basically for 2011, 2012, for Germany, they characterize occupations in terms of similarly to what Otto and Dawn have used. So there's analytical non-routine, cognitive routine, manual, and so on. Okay, so we're going to use that's what we use.
So, but isn't the choice of the technology of how the internet also will be endogenous reflected and the line heterogeneity across regions? Yes. Or is that the only way you could adopt it?
So for Germany, these authors make a very strong argument this was the only way you could adopt the internet because it was extremely, so everyone eventually gets high-speed DSL, but the timing varies a lot. So it's really just about when you got it. Okay, so, and these authors make a very strong case that it was not about preconditions, it was just, it happened that the telephone networks a certain way, and that's what we get. So we are going to control for a number of pre-existing district characteristics, just to, so things like the manufacturing share that you might think would be correlated with the decision to adopt internet, but yeah, so we're relying mostly on their argument. The one caveat here, which I should be clear about, is that the actual variation is at the municipality level, which is very small, and we have only district level data. So the FDZ has unfortunately stopped giving out municipalities to anyone, so we couldn't do it at the as micro level as that paper did. So we aggregate the instrument to the district level, and so that creates a little bit of noise. Okay, so we have good first stages. So we have two instruments. The first instrument is the number of municipalities inside a district that did not have their own MDF and whose population center was too far from the existing MDF that they were assigned to get internet through the copper wires. The second instrument is going to be number of municipalities that satisfy condition 1, but in addition have no other MDF anywhere nearby within the threshold that they could just lay some copper wire lines down to, which would be the cheapest way otherwise of getting internet, and getting high-speed internet. And so they didn't have any of those items.
Are you interested in the share of households or share of firms?
That's a very good question. So unfortunately, this data, the internet access data, is only about the share of households. So we're making an implicit assumption that there's less. Yeah. But again, we think that if anything, it's going to bias us against finding anything. So if the firms, if anything, should be adopting internet faster, right? So we should get less of a differential response. So we're actually estimating a differential response between early adopters and late adopters at the end. And so we should get less of a differential response at the start.
The question is, since this is all forward-looking behavior, so what was this, at this time in Germany, what was the discussion? I mean, these firms who didn't have it, were they expecting to get in a year? In 2 years, because since this is about technology adoption, this is very important.
Oh, that's a really good question. I don't know.
What was the context of it?
So Germany was a late adopter of high-speed internet, a very late adopter. So I'm assuming that my prior would be that the firms knew that they were going to get it in a year or 2 years or relatively soon, because everybody else already had it at that point. But I can look into that, because I'm sure that I can look at like the news discussions.
It is still part of the German public debate that there are actually still rural areas where right now there's no broadband internet yet.
Oh wow!
So that's not very common.
Okay, so
the data discussion is more about broadband, like mobile internet adoption, which is very backwards in Germany. But I think this.
Great, thank you. I was just gonna. So my husband is German. I was just gonna ask him what they were doing. But I do agree that whenever I go to Germany, I find like the internet is so slow. It's not a rural area, but okay. Okay, so. This is also only for West Germany. So the same things didn't apply for East Germany because they built their telephone network differently, and so we can't do this for West Germany, for East Germany. So let me show you what happens to our between inequality measure in response to the shock. So we're basically just estimating local projections here, and you can see that internet access started spreading after 2000, and you can see the inequality going up. How many minutes do I have left?
2.5.
Perfect. Okay. Yeah. So we think that
This is no migration, right?
So the advantage of using districts is then we have relatively big areas. So there's not that much evidence on migration between districts. If we were at municipality level, we'd be concerned about this. But districts, we have 325 districts for Germany, which is So we can see that inequality increased substantially, and we can do this back of the envelope calculation that suggests that the shock explains about a quarter of the increase in inequality over this period. And then I want to also, in the last minute, show you some of our preliminary results on the reallocation of workers, which we saw in the aggregate that young workers are shifting towards the high skills, the analytical intensive occupations, but we also see that in response to the shock. So we think that that's really interesting. So in response to the shock, the employment of young workers in early adopter districts increases, and the employment of old workers decreases. And then when you compare what happens to old and young workers in routine jobs, so this is routine, the opposite of non-atypical. You see that the employment of young workers is falling in routine jobs, and of old workers is really increasing quite substantially in routine jobs. So we think that this is really direct evidence of the mechanisms that we're having in the model. So we're going to do a lot more in testing what the model says about reallocation in more detail. We want to look at the wages of movers versus stayers. We've started working on that, but we don't have anything disclosed yet. And I'm hopeful that if you see this again, we will have it at that point. But let me also just mention what we're going to do in terms of estimation. So once we've already estimated the response of inequality, relative employment, we have to do output. So we're trying to get data on output. The data doesn't have output in it, so we need to bring in external data. With the empirical impulse response functions, we're going to match them at different horizons to the theoretical impulse response functions that we derive from the data. And we can use that to estimate the parameters. So this cost parameter, the birth rate parameter, and this parameter governs how heterogeneous the distribution of cognitive skills is. And so the intuition is that the short run response to the shock tells us about how heterogeneous the distribution of skills in the economy is. And then the medium run informs us about what the costs of adjusting skills and entering and exiting cohorts are. So that's our plan, but we're not there yet.
That's not what we show. Not even the data they show is different.
No, it's not different.
It's a different.
Yeah, so I didn't have to talk about it, but I have actually, we've worked out how to, yeah. So this is what we actually estimating the data, right? So we have early responses and late responses, and what we estimate is the difference between these. So actually, when you see, when we see some slight zero. Okay. Thank you. So when we see these when we see a decrease in inequality towards the end or flattening out, that doesn't necessarily mean that we have a beta shock with non-monotone convergence. Okay, so but we have to basically get the area under this to figure out what the actual response is. So we know how to do that. We're going to do that. We haven't done that yet. Okay, let me conclude. So what we're doing here is we've built a theory to think about the adjustment process to new technologies. And this theory has very simple and clean predictions about the dynamics of inequality output and worker displacement. And then we also have a methodology for using these transitions, which we can estimate in the data to actually discipline the quantitative exercise we're going to do in the model. And our application is a nice quasi-random internet shock, which we think is a good fit for what we want to actually do here. And so we're hoping that we'll be able to make long-run predictions about inequality in output given what we see in the transitions, and say whether we're in a monotone or an overshooting case. So that's what's going to come next. And then obviously we can think about what the shock teaches us about other kind of other technological shocks and how the economy might adjust.
Given your emphasis, I thought you were going to show us results on, take two districts, one adapts and one doesn't adapt. You'd expect that, skill printing going up in the district that adapts and the districts don't, something like that. Because here you are focusing on this between sector inequality, but those sectors are scattered across different districts, so it doesn't.
I agree.
It doesn't speak to the underlying mechanism. If the story is district, you need to show something that districts are getting differently.
I mean, so the responses are about early and late adopters, and the relative employment is trying to speak to that, but we're going to try to get the relative employment.
Inequality part is
not so. We need to estimate the impact on inequality because we need that for the estimation. But we are going to do it also with the. I mean, it's just we're hoping to have more at this point, but it's been a little bit slow to get out.
Good. Thanks very much.